Systems of equations, once you learn the process, there's some application that we can do in situations because we now know how to work with that. And so when you're working with applications of systems of equations, what you want to notice is that you'll have two sets of information. And so since you have two sets of information, you want to write two equations. When you're working with multivariables or multiple things that you're looking at, you need as many equations as you have variables. So what we're going to do is we're just going to work through some application of this, and we're going to be using what we know about systems. So in this example, it says the cost of a ticket to the circus is $25 for children and $50 for adults on a certain day. Attendance at the circus is 2,000 and the total gate revenue is 70,000. How many children and how many adults bought tickets? So let's go back through that and grab the information that we need. And so we know that tickets for children are $25. Adult tickets are $50. We know that the attendance on that particular day was 2,000 and that the revenue was 70,000. And so let's set up two equations because we're looking at children and adult, two sets of information. And so first one we want to set up is attendance. Attendance-wise, if I take my children and add the adults, I should get 2,000 people. Then I'm going to set up one based with revenue. And so I would say, okay, it costs $25 per child plus $50 per adult. And once we charged those bases, we gathered a total amount of $70,000. And so what we're going to do is we're going to use our two situations to create two equations, and then we're going to solve them by system. So you can see in this situation, we had a quantity equation and we had a money equation. And that's how we can kind of result some of those things, and we'll see this in problems to come. So in this case, which system solving method do I want to use? It says substitution or elimination, and it doesn't matter. Just do the one you think is going to be best for your situation. And in this one, what I'm going to do is I'm going to solve this one by substitution. The fact that it has some singular variables in my first equation, I think that's going to be the best go at it. And so what I'm going to do is I'm going to step one, I'm going to solve for one of those variables. So I'm going to get A by itself by subtracting C over, and that gives me 2,000 minus C. Step two of substitution is to plug that into the other equation. So I'm going to plug it into the second equation for this A. So it gives me 25C plus 50 times 2,000 minus C equal to 70,000. Once I have substituted it back in, I can now just distribute and solve. So it gives me 25C plus 50 times 2,000 gives me 100,000 minus 50C equal to 70,000. Then I'm going to combine like terms and solve for C. So 25 and negative 50 give me negative 25C plus 100,000 equal to 70,000. Subtract the 100,000. Gives me negative 25C equal to negative 30,000. And divide by negative 25. So C is equal to negative 30,000 divided by negative 25, which is 1,200. Now, once you get a value for one of your variables, remember step 3 was plug it back into one of the other equations. I'm going to plug it back up into the first equation because it's got some simpler arithmetic in order to solve, but doesn't matter. I would subtract the 1,200 over. It gives me A equal to 800. So that means how many children and how many adults bought tickets? That means we had 1,200 children at the circus that day and 800 adults. Now we could go into step 4 and we could check our answer. We could plug in those values and we get 2 true statements. So you can always check your answer, especially because we have so much things at play. But I just want to show you in this example on how to create your equations and then apply what you're doing with substitution and elimination. Now in the next example, I want to show you how to set it up, and then we'll work this one by elimination just to kind of verify we know how to work that process. It says you and a friend go to Tacos Cohilo for lunch. You order 3 soft tacos and 3 burritos, and your total is $11.25. Your friend's bill is $10 for 4 soft tacos and 2 burritos. How much do soft tacos cost? How much do burritos cost? So in this situation, we're setting up 2 equations, and it's not quantity and money, but it's based off what did you buy and what did your friend buy. So you bought 3 soft tacos and 3 burritos, and your total was $11.25. So if I did 3, we'll call them T for taco, plus 3 burritos, that total $11.25. Your friend's bill is $10 for 4 soft tacos and 2 burritos. And so 4 soft tacos and 2 burritos totaled $10. So now we have 2 equations, 2 variables, and we're going to set this up and solve. So again, we were just setting up an equation for you and your friend. Now I'm going to solve this one by elimination for 2 reasons. One, to make sure we understand how to solve by elimination since we did the previous application with substitution, but also because you can see if I'm looking at all these different variables, none of them are by themselves. So elimination really might be the best method for me. And so what we have to do in step 1 of elimination is we are going to have to create opposites on one of these variables. So I'm just going to rewrite the problems here. And what I want to do is I want to create opposites on one of them. I'm going to create opposites on the soft tacos. And so in order to create opposites on these equations, I'm going to have to multiply through by something. 3 and 4, the common or least common multiple between those is 12. So I'm going to create 12s on these, and one's going to be opposite. So I can do 4 times that 3 to give me a 12. And I'm going to have to multiply everything in the second one by -3 to work that out. So to create these opposites, I'm going to distribute this 4 throughout, this -3 throughout. It's going to amp up my numbers, but that's okay. As long as I'm doing it everywhere, the problem's not changing numerically in value. And so that would give me 12t plus 12b equal to 4 times 11.25, which is 45. Then I'm going to do -3. I'm going to distribute it, so it gives me -12t minus 6b equal to -30. Step number 2 in elimination is to add these 2 together. So 12 and -12 cancel. That's the whole reason we want to create those opposites. 12 and -6 give me a 6b equal to positive 15. And I could say $15 to keep it the same. And then divide everything by 6. So we have b equal to 250. And so this gives us a way to solve for burritos. It said, how much did your burrito cost? We know that the burritos cost now $2.50. Next, step number 3 is to take what you have and plug it back in. Step number 3 was solving for that variable. Just going back to my elimination steps here. Step number 4 is to plug it back into one of the original equations. So I'm just going to plug it into the top one. My top equation was 3t plus 3b equal 11.25. I am going back to the originals, not these amped up ones over here. So that gives me 3t plus 3 times 250 equal to 11.25. And I'm just going to solve for t. So 3 times 250 gives me 750. And then I'm going to subtract 750. So it gives me 3t equal to 11.25 minus that 750 is 375. And divide. So t is equal to 1.25. So this tells me that the soft tacos cost $1.25. And again, you can take this into step number 5, and you can check your answer just by plugging in what you got for t, b, and plug them into your originals and see if you get some true statements, and you will in this situation. And so applying these, we definitely can create equations from situations. The next example I want to look at is one where we're going to have to rely on some previous knowledge to create those situations. So let's read through it first. It says Marcus drove home from college traveling at an average speed of 68.2 miles per hour and drove back to the college the following week at an average speed of 65.1 miles per hour. If the total round trip took 10 hours, how much time did it take Marcus to drive from home back to college? Express the time in hours and minutes, round to the nearest minute. So let's just kind of draw out what we see going on here. And so here is college, and here is home. And so we are just looking at the path that he's taking from college to home and how fast he's getting there. So it said he drove home from college traveling an average speed of 68.2 miles per hour. So 68.2 miles per hour. And then it said he drove back to college the following week at an average speed of 65.1 miles per hour. So when he went from home back to college, that's where he went an average of 65.1 miles per hour. And it said, if the total round trip took 10 hours, how much time did it take to him to drive one of these directions? And so that means if the total time it took was 10 hours, say we were tracking how long it took him to get from home to college, we would then take our 10 total hours and subtract out that trip of T, and that would give us how long it took him to get from college to home. Now, in this situation, we're looking at time, we're looking at distance, and we have a rate. And so this is where your previous knowledge is going to assist you. The formula distance is equal to rate times time is how we're going to be able to set this up. And so we're going to set up two situations here. We know what was from college to home, that we would have to say the distance is equal to our rate, which is 68.2, times our time, which was those 10 hours minus T. We would also say, what is it from home to college? Again, using our distance equals rate times time. So our distance is equal to our rate of 65.1 times our time, which we called that T. Now, in this situation, what are we going to do in order to solve this? Well, we are just going to use a substitution method in order to solve. Now, our D's are the same distance because college to home, it doesn't matter how fast he was going. We're taking the same route to get there. It's going to be the same distance. So let me go ahead and distribute this piece here. So this would be 682 minus 68.2 T. And so using a substitution method, I'm going to set these D's equal to each other. So that gives me 682 minus 68.2 T equal to 65.1 T. And then I can solve this out. So I'm going to get my T's together. So I'm going to add 68.2 T. So it gives me 682 equal to, add those two together, that's 133.3 T. Divide both sides by 133.3. And that gives me T equal to, that division would be 5.12. Now this is in hours because we were doing miles per hour times hours, and that gave us the distance of miles. So this tells me that in 5.2 hours is how long it took me to get, let's see, T is representative of right here, our direction of going from home to college, which is what we're asking. If the total round trip took 2 hours, 10 hours, how much time did it take to drive from home back to college? So we can see it took us 5.12 hours. It asked for us to Find the time in hours and minutes. So we're going to have to do a conversion here. So we know that it took 5 hours. We need to figure out what 0.2 hours is in terms of minutes. So we're going to convert this to minutes. So that would be 0.12 times, there's 60 minutes in an hour. So that gives me 7.2 minutes. So how long did it take him to get from home to college? 5 hours and 7.2 minutes. So this situation did involve two equations, like what we were seeing with our substitution and elimination, etc. But at it, we had to know our distance equals rate times time. And then when we solved it out, we had to convert our unit into hours, minutes. So I hope this helps with the application of your systems.